Water must be fed into a boiler to replace the water which has been converted to steam. A common method of achieving this is known as on-off level control. When water level falls to a predetermined point, the feed pump switches on and fills the boiler to the required level, and so the cycle is repeated. It's fairly simple to implement, but it does disturb the delicate balance inside the boiler. This can best be demonstrated by comparing the situation to that of a container of boiling water, which is producing a steady rate of steam to the atmosphere. Suddenly adding an amount of cold water has a dramatic effect. It immediately lowers the water temperature and suppresses the boiling rate. Consequently, the steam production rate has dropped and cannot resume until all of the water has been brought back up to its boiling point. This is a disadvantage with on-off level control. These same effects can be seen in the boiler, but because they happen over a longer timescale, they are less apparent. Time-lapse photography provides a clearer picture of events. As soon as the feed pump switches on, the boiling rate becomes suppressed and the level falls. When the pump switches off, the boiling rate slowly recovers and the level continues to rise above the pump-off position due to the reappearance of normal steam bubbles. Notice how a mist forms just after the feed pump switches on. This is because steam is recondensing in the steam space due to the sudden lowering of the water temperature. The mist disappears soon after the feed pump switches off as the temperature begins to rise. So with on-off control, not only does the water level continue to rise and fall, but so too does the steam output rate. These effects can be reduced by preheating the feed water. The higher the temperature, the quicker the boiling rate can recover. Higher temperature feed water also reduces the need for oxygen scavenging chemicals. A far better method of water replenishment is to have a continuous but variable feed of preheated water to keep the boiler running in equilibrium. By carefully altering the feed rate to match any change in steam demand, the level is maintained at the optimum position with little fluctuation. In a boiler, this is known as modulating control. The result is a steady flow of steam and a balanced boiler ready to respond to changing demands.